Common questions students have in net ionic equations is what does and does not break up when you're writing the net ionic equation. So let's talk about this a little bit. So first of all, things that do not break up. You do not break up solids, liquids, or gases. So only aqueous breaks apart in net ionic equations. You do not break apart aqueous weak acids or aqueous weak bases. If you have a polyatomic ion present, if it's in a compound or if it's on its own, you do not break apart the polyatomic ion. Now, if it's in that ionic compound and it's combined with something else, then it would separate from the other, usually cation, but the group itself does not break apart. Molecular compounds also do not break apart. So that would be things like hydrocarbons, water, carbon dioxide, oxygen, anything like that that is made up of only nonmetals. On the other hand, these things do break apart. So anything that is written or told to be aqueous, and then all strong acids, HCl, HBr, HI, H2SO4, HNO3, and HClO4. All of these in AP chemistry are considered to be strong acids, and so anything else would be considered to be weak. Strong bases also fully dissociate, and so that would be group 1 and 2 hydroxides. So any hydroxide from column 1 or column 2. And then aqueous ionic compounds with snap ions, sodium, nitrate, ammonium, and potassium, those are the snap ions, are always considered to be fully soluble and therefore will completely break apart. So these are general rules. Now, anything else, you're going to get information from the prompt. So a couple different examples for you. So to start the reaction between HF and NaOH. So HF is a weak acid, so we are going to leave it associated on the reactants, and then NaOH is a strong base, so it is going to dissociate. Now that Na plus is a snap ion, so it will not appear in the reactants or the products. It's going to be a spectator ion, and therefore it is not represented at all. So then this is an acid-base reaction. So then that hydrogen transfers from the weak acid to the strong base to form water. Water is a covalent compound, so it is not going to be dissociated. And then F minus is what is left over. That is your conjugate base, so we would represent that. So then your second example is the reaction between silver nitrate and sodium chloride that forms a solid. So as I was telling you, there's some information here that tells you that you're forming a solid. And so then your job is to figure out what that solid might be. So we know that nitrate is a snap ion, and so it will not form a solid. It's going to stay dissociated. Sodium is also a snap ion, so it's going to fully dissociate. So we're going to expect snap ions to always be spectator ions. So then that leaves your Ag plus and your Cl minus to come together to form your solid. So your solid in this case must be AgCl.